All right, welcome back. I'm going to go through some examples of using this method for solving first order linear differential equations with the integrating factor approach. Step 1 is to make sure our differential equation is in standard form, which is y prime plus p of x times y is equal to q of x. I'm actually going to put the y in front of the p of x. And we'll just compare what we have to what we want. We have a function of x times y, and we have a function of x on the right hand side. So it's all matching up. Y prime plus y times 3x squared is equal to 8e to the x. So we have p of x is equal to 3x squared, and q of x is equal to 8e to the x. Step 2 is to find the integrating factor. And that's where we'll stop for this problem, since it only says to find the integrating factor. It does not say to solve. I may have misspoke. Find the integrating factor. I of x is e to the integral of p of x dx. So let's first find the integral of p of x. Integral of p of x dx, so that's the integral of 3x squared, which is x cubed. We get a plus c, but we can ignore the plus c for the integrating factor. It'll give us if you go through and include it, it's not that it's wrong. You'll have e to the power of the integrating factor, so e to the x cubed plus c. Use exponent laws. You can write that as e to the x cubed times e to the c. And then e to the c is just a constant, so you'll have a times e to the x cubed. And you'll have that constant a appearing in the denominator here in your integrating factor, and the numerator here in your integrating factor, and the a over a will cancel. That's why you can ignore it. So I'm going to ignore it. So we just get x cubed. Oh. Now our integrating factor, I of x, is e to that thing we just found. So e to the power of x cubed. That's it. That's the whole answer. If we want to continue, step 3 would be just our solution. Y is equal to 1 over integrating factor, 1 over e to the x to the 3 times the integral of e to the x to the 3 times 8e to the x dx, which is not a possible integral to do. And then step 4, use some y of a is equal to b to find the constant. But neither of these steps are needed for this example because it just says to find the integrating factor. Integrating factor, not needed here. Just get I of x. Okay, here's a second example where we're only after the integrating factor. Cos of x y prime is equal to e to the x cos of x plus y sine of x. And our first step is going to be important here. We want to put this into standard form. Put into standard form. It's really, really, really important. It is exactly how it's supposed to be for standard form. So I'm going to write down what it has to look like, that y prime plus p of x times y is equal to q of x. And right now we don't have that. So I'm going to divide both sides by cosine of x. The y prime has to be all by itself. So y prime is equal to e to the x cosine of x over cosine of x plus y times sine of x over cosine of x. We get a cancellation. Now I need the expression to be y prime plus y times p of x is equal to q of x. So I got to bring the final term on the right over the left hand side. So y prime minus y times sine of x over cosine of x is equal to e to the x. And it's still not right. It's still off because it has to be plus, not minus. It has to be a plus there, not a minus. Need y prime plus y times p of x is equal to q of x, not y prime minus y times p of x is equal to q of x. So how do we fix that? It's really dumb. It's so dumb. I'm going to put a plus sign there and just absorb the minus sign into a bracket. So minus y, or I'll put the y plus y here, plus y, and then we have minus sine of x over cosine of x. That's all. So we have to make sure it's a plus, and that means that our p of x will have that negative sign attached to it. Now it's in standard form. Now standard with p of x is equal to negative sine of x over cosine of x. Step 2. Find our integrating factor. Find I of x is equal to e to the integral of p of x. All right, so let's first integrate p of x and then stick it into the exponential function. So we have integral of p of x dx is equal to negative integral of sine of x over cosine of x. This is an integral that we can solve with substitution. I'm going to let w equal cosine of x. So then dw by dx is negative sine of x. And that means dx is equal to negative dw over sine of x. So we can plug that in. Negative. So we get positive, the two negatives cancel. Integral sine of x over w times dw over sine of x. You know what? That's going to cause confusion for anyone reading it later. So I'll do it in the next line. Okay, now the sign is going to cancel top and bottom. Now I'll combine those negatives together. So we have integral 1 over w dw, which is ln absolute value of w, but because it's a differential equation, I'll drop the absolute values. Like, that's not why I'm dropping it. I'm dropping it because it'll get taken care of. We get the plus c. We can ignore it for reasons already described. But what we should do is we should put this back in terms of x. So ln of cosine of x. Thus, our integrating factor which is e to that power, e to the power of that function, the e ln cancels. and we get something very compact and innocent looking, just cosine of x. That's our answer. And if we wanted to continue, then we would do 1 over cosine of x times the integral of cos of x times e to the x, which would not be a very nice integral, but it's one that we have the tools necessary to solve. Okay, another example that we're going to have to do some playing around with to make it work, make it look like standard form. Y prime plus y times p of x is equal to q of x. So our first step I'm going to do is I'm going to multiply all 3 pieces by x, so just to get the y prime all by itself. So y prime plus 3yx over x squared is equal to 3x. And then cancel the x on top and bottom of the second term there. So y prime plus y times 3 over x is equal to 3x, simplifying, factoring the y out front. Now this is standard form. So p of x is equal to 3 over x, q of x is equal to 3x. Now step 2, find the integrating factor. Okay, so our integrating factor, let's find the integral first, integral p of x. Integral p of x dx is equal to the integral of 3 over x dx, which is 3 times ln absolute value of x, but I'll drop the absolute values and we'll ignore the plus c. Okay, now step 2 part B, I guess. Once we have the integral of p of x, then we find I of x. I of x is e to the integral of p of x. So e to the 3 ln of x. We can't cancel right away. What we have to do if we want to simplify it is using a log rule. Bring the 3 up as a power. And now we can use the cancellation law. And our function is x cubed. That's our final answer. That's our integrating factor, x to the power of 3. Okay, this question is asking us to do the entire thing. Find the integrating factor and then solve. So we're going to have part 3 afterwards. Part 1, put it into standard form. So we want y prime plus y times p of x is equal to q of x. We don't quite have that. It's very close though. So we'll have y prime plus y times 1 over x is equal to negative x squared. That's all we had to do. Just factor the y out front. And it's otherwise in the correct format. So now it's standard form with p of x is equal to 1 over x and q of x is equal to negative x squared. Now we do step 2, find integrating factor. So first we integrate p of x. So integral of 1 over x, which is ln absolute value of x, but drop the absolute values, plus c, drop the plus c, because it's integrating factor. Okay, now we can say that I of x is equal to e to the integral of p of x, which is e to the ln of x. And we just get a straight cancellation law. We don't have to bring any numbers up as powers. We just get x. And for the last few examples, this is where we were stopping, but the question asks us to fully solve. So now we're going to do the magic formula. Use big formula. So y is equal to 1 over I of x times the integral of I of x times q of x dx. So 1 over x times x negative x squared dx. We have to simplify the inside. And as a warning, like a really important warning, you cannot have the 1 over x travel into the integral. It's outside the integral. So no cancellation, like don't cancel the x on the bottom with that x on top. That integral protects the contents from stuff that's outside. The only thing that can travel past is a constant. Variables, or at least the variable of integration, cannot travel through. The minus sign, I can bring that out front, that's fine. We have integral of x to the power of 3. What's the antiderivative of x to the power of 3? It's 1 over 4, x to the power of 4 plus c. Now the next part is extremely important. I'm going to multiply the 1 over x into that bracket. So we'll have x to the power of 3 over 4. Well, I'll do 1 over 4 x to the power of 3. 1 over 4 x to the power of 3. We had x to the 4 on top, divided by x, so just x to the power of 3, plus c over x. It has to have this form. It's not plus c, it's plus c over x. It's extremely important. Not 1 over 4 x to the power of 3 plus c. It has to be c times x, otherwise it won't be a solution to the differential equation. It won't work. If you want, if you feel like it, I'm not gonna, I don't think it's a good use of your time to check every single solution when you're doing homework problems or doing the notes. But if you feel like it, check at least one of them. Make sure that if we take the derivative of this function and we add this function divided by x and simplify, we get negative x squared. Because if it doesn't work out that way, then we made a mistake at some point in our solving process. All right, another example. Solve the differential equation. This time there's an initial condition, y of 1 is equal to 10. And we're going to use that to find our constant, or c, that will come out. But as usual, we got to do our steps. Our format, standard form. We want y prime plus y times p of x is equal to q of x. We currently don't have that. So I'm going to start by dividing all the pieces by x to isolate for y prime. So 5 over x times y is equal to 6. So it's in standard form. We have p of x is equal to 5 over x, and q of x is equal to 6. Step 2, integrating factor. Find I of x. So we're going to find integral of p of x dx, so the integral of 5 over x, which is 5 times ln of x. Then we're going to find I of x as e to that power. And we're going to bring the 5 up as a power. And we get x to the power 5 after doing cancellation law. Now step 3, we're going to use our formula, big formula. So our solution, y is going to be equal to 1 over the integrating factor times integrating factor times q of x, antiderivative. Let's plug in the integrating factor, 1 over x to the power 5, integral of 6 times x to the power 5. When we take the antiderivative of 6x to the 5, we get x to the power 6. So 6 times 1 over 6, x to the 6. The 6 and the 1 over 6 cancel. Plus c. And then we can simplify that. X to the 6 over x to the 5 plus c over x to the 5. And then x to the 6 over x to the 5 is just x. So x plus c over x to the power 5. Now we need to find c. If y of 0 or y of 1 is equal to 10. So step 4, find c using y equals 10 when x is equal to 1. So 10 is equal to 1 plus c over 1 to the power 5. So 10 is equal to 1 plus c. That means c is equal to 9. Thus, we can write down our entire solution. Y is equal to x plus 9 over x to the power 5. And that solves the differential equation. It's mechanical. Put it in standard form. Standard form is what allows us to use all these formulas. Part 2, find the integrating factor. Plug the integrating factor in step 3 into the big formula. Integrate, simplify. In the last step, step 4, use the initial condition to find the constant that will come out of that last integral. And then it's always important to state what the final answer is. Don't just say c is equal to 9 and leave it there. Put it in. Write out what is the final solution. What is y equal to? Wow, lots of examples. Okay, good. So this one does not have an initial condition to it. Let's go ahead and see how we're going to solve it. Step 1, standard form. And you might trick yourself into thinking that p of x is equal to 5, but it's not. Y prime minus 5y is equal to e to the 6x. So y prime plus y times negative 5 is equal to e to the 6x. Now it's in standard form with p of x is equal to negative 5 and q of x is equal to e to the 6x. It's so important that you get the pluses and the minuses right. It changes everything. It's not off by a little bit, it's just completely different. Okay, step 2, find I of x. So first we integrate p of x. That's the integral of negative 5. But that's a nice integral to have, just negative 5x. Then we get I of x as e to the integral of p of x. So e to the negative 5x. And that doesn't simplify, nothing cancels. There's no log. It's not e to the negative 5 ln x, that would cancel. That would simplify, this one doesn't simplify. Okay, step 3. big formula. So y is equal to 1 over I of x times the integral of I of x times q of x dx. So that'll be 1 over e to the negative 5x times the integral of e to the negative 5x times e to the 6x. And we're going to use some exponent laws. We're going to use that 1 over b to the negative m is the same thing as b to the positive m. Well, if you want, you can write it this way, b to the negative m, which is b to the positive m. So we can bring that up as an e to the 5x on top. And we're also going to use the fact that b to the m times b to the n is b to the n plus n. We're going to use that on the right hand side, or inside the integral rather. So this is e to the 5x times the integral of e to the x dx. Negative 5x plus 6x is 1x. The antiderivative of e to the x is e to the x plus c, which we can expand e to the 5x into there. We get e to the 5x times e to the x plus c e to the 5x. We're going to again use an exponent law. We get e to the 6x, since the exponents add, plus c e to the 5x. And that's our solution to the differential equation. And we don't have an initial condition to find c. If we did, this is where we would plug it in. Okay, last standard example before we get to the non-standard ones. Differential equation, lots of stuff is wrong. I'm going to get it into standard form first. Let's divide both sides by -2. So y prime is equal to negative 1/2 x minus y. Then let's add y to both sides. So y prime plus y is equal to negative 1/2 x. And I'm going to write y times 1, just so we have something. P of x is equal to 1. Q of x is equal to negative 1/2 x. Step 2, integrating factor. So we're going to find p of x integral. So what is the antiderivative of 1? The antiderivative of 1 is just x plus c. We ignore the plus c. Now we find I of x as e to the integral of p of x, what we just found. So just e to the x. Now we go step 3, big formula. Y is equal to 1 over integrating factor, 1 over e to the x, times I of x times q of x. So e to the x times negative 1/2 x dx. I can bring the 1/2 and the negative out front. E to the x in the denominator is e to the negative x in the numerator. And we have an integral of x e to the x dx. I'm going to do that integral off to the side. How do we integrate that? Well, it's one of our integration by parts, IPP. Late, we don't have any logs, but we do have an algebraic. So u is going to be x. That means du by dx is equal to 1. So du is equal to dx. dv is equal to e to the x dx. So v is going to be the integral of e to the x dx, which is just e to the x. So we'll plug all that into our IBP formula. Integration by parts says if we're integrating u dv, we'll get uv minus the integral of v du. So we said that u was x, and v was, we found e to the x. V is e to the x, du is just dx. We can integrate, we get x e to the x minus e to the x plus c. And then that's what we'll plug in down below. Okay, so we have minus 1/2 e to the negative x times the solution we just got over there. X e to the x minus e to the x plus c. And we expand that into the bracket, expand all that in. So minus 1/2 x e to the negative x times e to the positive x plus 1/2 e to the negative x times e to the positive x minus c over 2 e to the negative x. And then there's two pieces there that we can simplify. B to the m times b to the n is b to the m plus n. And b to the 0 is equal to 1. If we use both of those statements, or both of those properties at the same time, we get negative 1/2 x times e to the 0, so times 1, plus 1/2 times e to the 0, so times 1, minus c over 2 e to the negative x. It's not a very nice looking answer, at least to me. I look at this and I'm like, how does that, not very nice expression, how does that come out of what we just did? Out of that negative 2y prime is equal to x plus 2y. Nothing in there screams exponential function or negative exponential function, but that's exactly what came out.